big one today, and it's really the only one we're going to look at, because well, it's complicated for one. I'm not going to get into a lot of nuts and bolts. I'll just tell you that the people who study this stuff are about as smart as ecologists, and that is they have to know so many different aspects of science that it boggles your mind. There was a time in my life where I spent a few months trying to really, really, really deeply understand this stuff. And I got part of the way there, but I can just tell you it's hard. And so the hardest part of it is predicting what's going to happen in the future that's new. And so I'm not going to do that at all. There are lots of ideas out there about what's going to start happening as things get warmer and warmer. But those are really hard. New stuff happens every year. We just fairly recently found out that something we didn't know is that when permafrost, remember permafrost, the layer that never melts in the tundra? Well, when it does melt, it releases a whole bunch of new carbon into the atmosphere. And so there's this magnifying effect of tundras melting that we had no idea about. So we had to adjust models based on that. So that stuff's a pain in the butt. We're not going to worry about that. What I'm going to do is simply give you what's happened so far, because warming is happening. It's already happened. We've seen what it causes, and we'll just go with that. We'll say this that's already happened in the last 50 years, it's going to probably keep happening and get worse. Okay? So, number one, CO2 levels in the atmosphere are higher than they have been in the past 650,000 years, at least. Which, being very smart people, as you are, and having had the scientific literacy unit, as you did, you should have a question. You have a healthy degree of skepticism, because you know you should be looking for backup whenever anybody spouts numbers at you. What's your question?
How do they know what the CO2 level was 65,000 years ago?
I mean, we've maybe had the ability to measure CO2 levels for 75 years, maybe. 650,000 is crazy. So this is actually really cool. I get to talk about Antarctica again. What you do, this is neat, because the top and bottom of the Earth have been frozen for so long, every year new ice forms, right? They get new layers of ice. You know how you can tell how old a tree is by looking at the rings? You know how you can tell how old a fossil is by the deeper you go, you know the sediment formed at certain times in the Earth's history? Ice works the same way, especially when it's never totally melted. And so what you can do is take this big, huge hollow drill, and you drill down in one of those deep ice places. In Antarctica mostly is where they do it, call it ice core samples. And the thing is that when water freezes, it has a certain amount of dissolved gases and minerals in it that tells you stuff about the atmosphere. Like if water froze here right now, it would freeze with a certain amount of dissolved CO2 in it. And you could compare that to how much CO2 there is in the air and be like, okay, this proportionally means there's this much CO2 in the air. But you can do that with ice that froze 600,000 years ago and go, oh, there's this much CO2 in it. That extrapolates to there was this much CO2 in the air. So that's how we know. It's kind of cool. Temperature-wise, average temperature has gone up about 1 degree Celsius since before the turn of the second to last century. Which doesn't sound like much. But is because, well, number one, this isn't a huge deal, but you know about Celsius and Fahrenheit, right? The temperature scales are quite different. What's freezing in Fahrenheit? What's boiling?
A lot.
212. So we're talking 32 to 212. That's almost 200 degrees, right? In between freezing and boiling. How many degrees in between freezing and boiling? Same span of temperature in Celsius. 0 to 100. So 100 degrees versus just under 200 degrees spanning the same range of temperature means that Celsius degrees are fatter. Does that make sense? They're bigger. They cover more range. So that's one thing. But the most important thing is when we say temperature is going up, we mean global average temperature. To get a global average temperature, you measure the temperature at every weather station on Earth every day for a whole year and average them together. That number tends to not budge. It tends to go pretty rock steady. And for it to go up a degree in about 100 years is a lot. And we'll look at that tomorrow. I've got a timeline of temperature for you that compares different ranges, different changes. But for now, just know that a degree is a fair amount. So here's what's happened so far. Number one, droughts have become more frequent and more severe. It's one thing to hear about droughts, which we have for the past 10 years or so. We've heard about severe droughts in various places. When we really notice droughts, though, is not when people have trouble getting water. When is it? First time we really noticed it was about this time last year. Fires. Yeah. Remember when Australia was on fire? That was a year ago. Seems like 5 years ago, but it was a year ago. Yep. Then California, when like even people in like Colorado could smell smoke all day long because of the fires in California. Yeah, that goes with that, right? Hurricane. You understand this one because of our chapter 4 stuff when you looked at those videos. Remember seeing Katrina burn through the Gulf of Mexico and leave that trail of cold water? Hurricanes run on warmth. They run on warm water primarily. And so the warmer things are, the easier it is for hurricanes to become stronger. So it's not that there's more hurricanes necessarily. It's that the percentage that are severe has gone up. Those are ones you wouldn't necessarily know. The no-brainers to come here. Ice is melting. Snow is melting. You know about that. Your oceanographer knows about that in your group. Your fisheries biologist knows why melting sea ice is a problem. Fisheries biologist, why is melting sea ice bad for the Antarctic ecosystem? Yeah, this is weird, but there's algae that grows underneath sea ice. And so that is where krill, the little shrimpy things that make up essentially the base of the Antarctic ecosystems, that's where they make their little nurseries where they raise babies. And without the sea ice floating there, krill can't do their thing. Okay, that's one thing. What about glaciers melting? That's a much more direct human affecting problem. Why? Glaciers are ice on land, right? Not on the water. That's the difference. What's the difference between ice that's floating and ice that's on land melting?
Form like rivers.
Usually glaciers are pretty close to the ocean. So where does that water go?
The sea.
It's fresh water.
Two things. Number one, it's water going into the ocean, which means there's more water in the ocean, which means sea levels have gone up. Number two, though, Amanda's right. That's fresh water going to the ocean, which is weird. A little bit doesn't matter a whole lot. But if we're talking about big dumps of fresh water, actually has the potential to disrupt ocean currents, which has been something that's thrown out there. It's not something I talk about a lot because we don't know if it's really possible, but they made a movie about it. I can't remember what it was called, but there's the possibility. You know that warm current that washes up against Europe all year long and makes it warmer than it should for its latitude? A freshwater dump from the northern Arctic regions could totally shut that current down. And if that happened, we're talking an ice age for Europe and those people basically having to go somewhere else. And there's even speculation that enough ice over of a place like Europe could trigger like a global ice age, which, you know, like that's crazy. What was that called? What's the movie called? The Day After Tomorrow, is that right? No, it's something like The Day After Tomorrow, where it's suddenly ice age, like modern time ice age. You remember? You know what I'm talking about? Is that what it's called?
All over.
Yeah, yeah. That movie was like, it's not real, obviously, but it was based on like a Pentagon report. Like they were like, this could totally happen. And everybody was kind of freaking out. Looking at
I remember one that's like, I don't know, it was a cool movie. It had The Rock in it. It felt like a tsunami. Well, and then the dam broke and then the whole city.
oh yeah, Day After Tomorrow. That's it. I don't know if it's any good. I didn't watch it. Day After Tomorrow. Catastrophic climatic effects following disruptions of the North Atlantic Ocean circulation. Anyway. So yeah, sea levels increase. Now 4 to 8 inches doesn't sound like a whole lot, but I think it's like another 9 inches and half of Florida's gone, something like that. Like there's a lot of low-lying areas that people live on that they won't be able to as sea levels go up. Again, this is just stuff that's already happened that we can sort of extrapolate to say, it's going to keep happening. Temps and CO2 going up in the atmosphere means temps and CO2 going up in the water as well, right? Because it dissolves from the atmosphere into the water. It heats the water. First indicators that that might be a problem. Raise your hand if you've ever gone snorkeling in a coral reef. So cool, right?
When you get like modern.
Yeah, it takes practice for sure. And it sucks if you have facial hair because there's constant salt water going up your nose because the seal's not good. But do you remember when you were snorkeling, when whoever was in charge of you was like, yeah, you should go over here. Don't go over there because that's the part that's bleached. There's nothing living over there. This is the good part. Remember that? Did they say that? No? They usually say that. Because you were probably in the Caribbean when you went, and about 70% of Caribbean coral reefs have bleached. Bleaching means the water is too warm and too acidic for the coral animals. Coral animals, they're related to jellyfish. They live in these little buildings that they build, and they have little algae living in them that help them by photosynthesizing. When they get too warm and it's too acidic, they spit their little algae out. They can't photosynthesize anymore, and they bleach out and they die. And those coral animals are the basis for the whole reef ecosystem. So basically everything stops living. Now, coral reefs are really diverse. They're kind of considered like the rainforest of the oceans. And so the fact that they're going away, people consider sort of like almost like the canary in the coal mine, the warning that, hey, this is going to cause big problems. By 2050, the conservative estimates are 2 more degrees. How's the smart board? Is it easier to read than the projector was?
Yes.
Easier?
Yeah.
Cool, because it's smaller. Like the image is smaller, but you find it easier to read? Awesome. Hi.
Hi. Did you see Adrian during your 21st year?
No, he's Model B. You're welcome. Oh, because I keep disappointing her in front of you. Awesome. Yeah, got you. Miss Carmack. I hope she's still not listening. Yeah, so that's about as much as we're going to dig into there, except I do want you to see some of this for yourself. So tomorrow we'll have a couple activities where you dig into some of the data. Because one of the questions that you'll get a lot from people is, okay, great, climate's changing. Isn't that normal? Doesn't climate change just happen? Isn't that a normal thing? So yeah, the answer is yes, but this change is different from that change in several ways. So you'll see that tomorrow. Today, though, I really just want to give you time to work on sample essays since I didn't give them to you yesterday. The rest of the period is yours. I'm going to hand them out and let you work.